Okay, here's our motor class. This is round 4 of making a simple one-of class, so there's not much interesting in it. We've got a motor that's going to have a serial number, some amount of time it's been in service, and the manufacturer specifies how many hours it's going to take in service before we should do something like change the oil or totally refurbish it or whatever it happens to do. And so we wrote a few getters for each of the things. So those are the 3 getters that correspond to the 3 data values up top. And then we needed some way of updating. So this is actually a setter, right? It changes the value of a specific variable. So you can add more hours to the motor. And then to make life a little bit more convenient for people so that they don't have to do the subtraction, we've got a getter that does the subtraction for them and just says, well, here's the difference between maximum hours of service and hours of service, which is hours of service left, or probably can think of a better term for that, time remaining before service or something like that, hours remaining. So that's it. There's nothing exciting about this. What I want to do is add one more method in here. Let's just go back and see what I called it. Actually, a couple more. I want to add in something that says hours until it needs to be serviced, which I guess is what we have already. And I want to add in another one to say whether or not it's past service. Okay. The reason for the is past service one is just to show you how to do a Boolean. Okay, so for instance, we can write Boolean is past service. How do you know if it's past service?
It's more than maximum hours.
If hours left is greater than 0.
It's negative, it's less than 0.
Less than 0.
So here's one where we can make use of something we already had. If hours of service left is less than or equal to 0, then it needs to be serviced, and basically there's the other case, false. Okay, I wrote this one backwards. The other way you could write this is to leave this out and say the best case in the world is that it never needs service, so that's return false all the time. And then think of the reason, the bad case, oh my God, it needs service. When would I know it needs service? Well, if for some reason it's exceeded the maximum time, then it's due for service. Anything weird about that?
See you on choose one and the 0 can be confusing.
The 0 is in some senses a little confusing. It's past service if it's exceeded something typically, and in this case it doesn't look like it's exceeding anything because of that. So you could actually flip this around, right? There's some ways that we could flip this around, but you know, just automatically you start to think, well, this isn't quite right, right? So maybe there's a better way of writing this that would be more clear. That's maybe not the best. Okay, I'll let you think about that one for a while. Okay, so there's this idea of a Boolean that just returns true or false. Either it is or it isn't. How about some tests? Let's crack open our motors class here and make sure I've got the correct file selected. And then we'll do file, new, unit test, make sure we've got the setup method now that we know what it's used for, add the library, all set to go. Now we can start to think of some tests that we would want to write. How about one for seeing whether or not it's passed service? Just to get something more sophisticated. We'll make a new motor. Motor has a serial number, really doesn't matter what the serial number is, and it has some number of hours that the manufacturer says that before we should service it. Then we'll do a motor dot add hours of service. We'll add 6. Now what?
Insert H2.
What information are you looking for from the motor? Those are the things you're allowed to say. Let's ask it whether or not it's past its time for service. What's it going to give back to us? A Boolean. And then the assert statement, I think that time for service should be false because it's 6 hours and it doesn't have to be serviced until at least 10. Okay. If you want to do the simple test, you can run that and see whether or not it passes. This test is fairly uncomplicated, so I don't mind testing something else in here. So let's add in some more hours. How many more do you want to add?
More than past 10, just to check if it's.
What are the interesting spots to check? To see whether it's not due, to see whether it's actually due, and what's the other interesting spot?
Past due. Late.
Is it due at 10 or not? The middle ground. Okay? And not only that, but the question is also what happens at 9? Okay? Usually the one before is sort of interesting, the one before it's due, to make sure it hits up to where it's supposed to be. The one just when it's exactly due or not due, right? So 10 is the interesting case because we get to ask the question, is or isn't it due? The one right after, to see whether or not that one checks out, and then something in the future that's past the one after. Okay? So isn't it interesting that just for one number, there's those cases in the middle that are sort of amusing. So in this case, what I would do is I would actually add enough to get it to there, and then the answer should still be false. What's the next spot?
Let's not go to work here until 3, not 9.
Sorry, not 3, but that, and thank you. And then we'll do it again. And how many should we add?
1.
Just 1. So true or false? Well,
Well, Well, you know, according to your coding fault, that'll be.
What are your expectations? If I run it for 10 hours and the manufacturer says it doesn't need to be serviced for 10 hours, do or not do?
Do.
Interesting how that question comes up, right? I mean, we wrote the thing to start with, and we said, oh, 10 seems to be the number, and then all of a sudden, when you hit that line, it's like, well, should I service it at 10 or not? Okay? And this is where the unit test defines the expectations. So this is where the manufacturer would come along and say, either 10, it should be time for service, or 10, it shouldn't be.
10 it should be.
Okay? And I'm going to say it shouldn't be, just to be contrary, right? You can run it for 10 hours. After 10 hours, you need to take it in for service. Okay? Total choice there about which one you do, but there's the case where the unit test clears up any expectations about exactly how it's supposed to behave on that case. So now we'll add one, and then we'll add another one. Time for service or not? So in this case, it should be. So now I'm going to ask the question, is this look what's happening with this test. Is it still understandable?
Yeah. Yeah.
You're sure?
It might be more understandable if you. No,
6, 3, 3, 1, false, false. All of a sudden it's true. Why is it true now when it wasn't true before?
Because they hit it. You add them all together.
Because you've added them all together and you've decided that it's hit past 10. So what could I do to make this test more understandable?
You can make a new motor each time and add the whole thing.
You can just write 6 plus 3 for the first.
Yeah, the thing that's missing from this test is what makes it true in this case. Well, what makes it true in this case is that it's gotten to 11 or 10 in the previous case. Well, how did it get there? Well, we've got a getter for motor, I think, that gives what's the current hours of service. So let's just clean this thing up a little bit, and let's say here, I think that a motor dot get hours of service should be exactly 6. Got it? What should it be in this case if we add another 3? It should be 9 hours of service. Oops. And then down here, it should be exactly 10. And then here, it should have gone to 11. Does that make the test more understandable? Because now you can see, oh, 10, I now know why that original 10 is there. It makes sense then when it hits 10 and pops over that now all of a sudden we care. Is that a complete test? Any other values you want to test? What other value?
Do we test it going the opposite way? Or?
It can't go the opposite way yet, but ask that question in 2 minutes. Anything else that would just finish off this test?
Like 15 or 20.
Check 15 or 20. I would do one pass because that one just before and one after, the interesting one, just gives you that case just around that sort of center point, and then just one any place in the future after that to see whether or not it's still the case, because our expectation is that just because it gets over, it shouldn't somehow magically reset. It should keep staying over until you do something else. Okay, so we'll test this thing one more time, and we'll say if we add however many more, another 4, then we should hit 15, and it should still say it's ready for service. run that thing. Oh, wonder why it failed. Let's just go look at why did it fail on this test?
Because you have to be true about it.
There is no true it.
Where is the issue going to be? We could put a breakpoint here to try and find out. Where is the interesting spot that we should put a breakpoint? You can put it at the start of the test. How about there? Run with the debugger. Now, notice that unit tests do a whole bunch of crazy things to do setup in order to actually run the test. So there's a whole bunch of crud in there that's in the way. But sooner or later, you can see something that looks like our test, even though it has sort of a bad name on it. There's our test, and we're currently stuck right there. So the interesting thing is what's happening with the motor. Well, the motor has 9 hours of service. I'll check by adding another one. It's now 10. What's get hours of service doing? It's going to return 10. That's still fine. So that assert is okay. What's happening here? That's the interesting case, right? So let's just do a step into, and let's see what's happening. Here's the current motor with 10 hours of service. Maximum before service says 10. What should it be returning?
True according to yourself there.
What was the test expecting?
False.
False. So the test is saying 10 hours of service is still okay. It's when it goes over that's important. So we'll do one more step, and this thing is returning true to say when it should be returning false, because 10 should be valid. What can we do to fix this? Get rid of the equals. So we'll remove the equals, kill off the current set of tests. You can run again right from here by finding the bug and just running again. And now it's going to hopefully pass all the tests, although you can't see the tests as easily. So I'm going to flip back to the other view where I can see the tests, and I'm just going to run the unit tests, and they all passed. So this test has a bad name. We'll fix the test to say hours of service, something along that line. If you see a message like this, it just means that you've left a debug session running and you've changed some code. And so now it's going, well, hold it here. I was supposed to be debugging this code, but now it's different than the original code I was debugging. What should I be doing? The answer is, well, let's just terminate and crank it up again. So we'll run it again. And now we've got a decent name there. Okay? So in computer science, the cases that are interesting are almost always what they call the corner cases, the edge cases, the ones just before, on, and just after some sort of event, are almost always the ones that cause the bugs. And there's the joy of the unit test, is the unit test defined what behavior we were looking for, and then we could go back and make sure that the code matched the behavior rather than the other way around. Okay, so there's a test for the motor. We've now got something that we can sort of use. This thing isn't complete. There's a whole bunch of things I could test for the motor, but I'm more interested in moving on and using this thing for something useful. So let's make a brand new driver program. And let's try doing something with motors. So since I have one from the test, I'm just going to go steal it because I'm feeling lazy. There's a motor. Let's make another motor. I guess I'll do it the easy way. Steal that code. So this is motor B. Add some different number of hours of service. Make one more motor. Motor C. Give it some different number of hours of service.
Do you want to change the serial number? They all have the same.
Change some of this around a little bit. We'll give this guy, 5 hours, and we'll give this guy 8 hours, just to make them look a little bit different. Got it. So we've got 3 different motors.
Your labels are all A.
The serial number.
A motor,
Serial
Just
number.
like in
The
a
ceiling that you're passing.
oh, sure. Fix that, thank you. There we go. So now we've got 3 different motors. Let's suppose that they all belong to the same plane. Well, this is going to get a little boring. What should we do here instead of having 3 separate variables? I just want a bunch of motors. So basically I want a list of all of the motors that I've got so far rather than having 3 separate variables. So let's do that. A list of all motors turns out that Java already has a list. Be careful when you do the import statement. There's actually 2 different kinds of lists in Java. The first one is the GUI list, and the second one, the one that belongs to the utilities class, is the actual useful one for us. So there's a list of all of the motors. Any list actually exists? So to make a new motor, we'll use our friend new, and we'll say, I want a new list. Yeah, close enough. It's not even going to let me do that. Okay. These 2 lines normally go together. So rather than having the variable made and then turning around and giving it using new, you can run these 2 lines together, and we can just get rid of the variable and we'll do the declaration right there. Okay? Now, the interesting thing about lists is that lists can hold any kind of thing. Right? This is a list is a facility that just says I want to store stuff. Okay? So I could make a list called all motors, I could dump a bunch of motors on it, and then I could throw a cat onto the list. Okay? So chances are that wouldn't be a good thing, because if I'm making a list called all motors, my intention is that it's probably only going to be holding motors and not motors mixed with cats and furniture and whatever else. So in general, when you make a list, even though it's could be any type of thing, you want to limit that list to only having specific types of things. And in Java, the way you do the limits is you use angle brackets, and inside the angle brackets, you specify what kind of thing you want the list to contain. And you sort of kind of have to do it on both sides of the equation. Okay? And so it would look something like that. Almost. But it turns out that in Java, there's also more than one kind of list. Okay? There are lists that have different kinds of performance with them, and the one that you're used to using is probably this idea that you can have an array that's going to hold on to a list. And so I'm going to do another import statement for that thing. Okay, so the idea is the motor word limits the list only of this type of thing, And this thing says that when I make a list, I want a specific kind of list or a specific way that it's been done inside, which is use an array to store all the items. That's different than, say, having a database list that kept things in a database. This is just a simple form of list.
So why was it throwing a red underline when you just had it say list?
Because the list is a general term, it's not a specific term. So the thing on the right-hand side has to be a database list, a list with an array, a list that comes from a network, right? Versus the thing on the left-hand side is the general type of thing. For now, that's sort of just the way it's got to be. And the good news is that for our purposes, it's always going to look like this. It's always going to be list on the left-hand side and array list on the right-hand side, at least for a little while.
Motor. That,
The motor variable is there for two different reasons. On this thing, this is for the general list, and on this thing, this is for the specific kind of thing. It's sort of no different where here we said motor on both sides.
yeah, but when you declare now whatever models are on that list, you have to put motor.
We haven't got to that yet.
Okay.
Okay. Now, one other little trick here, it turns out that this gets really annoying fast to have to say only this type of motor on both sides of the equation. So in the most modern version of Java, Java 1.7, you can actually leave that thing off. Okay? But for now, I'm going to put it on just to sort of re-emphasize things and leave that there. How do you put a motor onto the list? Well, lists can do all sorts of things, but the simplest thing is to say I want to add one of the motors to the list. Well, if that worked, let's add the other ones in. Just steal list code. And I'll add in A, B, and C. Now they're on the list. Okay. How do I know they're on the list? What would I do to find out?
Yeah, that was it.
Do what? What would be the simplest thing if you wanted to
Ask the list to go.
old school thing? Print them out, so just run through and see if they all manage to get on the list. And this is, I'm just doing this so that you get to finally figure out what a loop looks like in Java. So here's one version of a loop. So I'll get the serial number and I'll print it out. Make that look like an R. And we'll print out the serial number. Let's give that a try. Just make sure it works, and then we'll go back and we'll talk about the loop. I can make this a little bigger for you. There's A, B, and C. Okay, so let's talk about this loop statement. This says, go through all the motors, grab a serial number for one of them, and print out that serial number. Okay? Here's an interesting fact about loops. Almost any loop you will ever see in your entire life, your coding life, no matter what that thing says for syntax, you can read it as go through all of these things and do something. Pretty much guaranteed. Okay? So there's a thing to get into your brain. Forget about reading the details of what the loop syntax says, no matter how complicated it is, and just say, go through all of them and do something. In this case, go through all of them and print it out. Okay? Now let's talk about the actual syntax, now that we know it means go through all of them. Well, there's all of the things that you want to go through. You need a variable that's going to hold on to them one at a time as you go through the loop. So that's the thing that's going to change within the loop. You have to describe exactly what kind of thing you're getting from all of them. So it's a motor that's stored on there. So that word has to correspond to what you put on the list initially. Okay? And then that's going to make sure that inside the loop, that sum motor variable changes for each of those values. Okay? So in this case, now that we've got sum motor to change, this is going to go get the first serial number, print it out, go get the second one, go get the third one.
That's like the index, the sum motor.
There's no index there. It's just the motor changes each time. You're not used to this kind of a loop, probably. Or you may be. What's the other form of loop that you've seen?
A while.
A while or anything else?
Or
For.
set loop next time.
The counted loop? The one where you go out and retrieve them by position? Okay, well, let's do one of those. We'll do the simple thing. If you wanted to get motor number 2 off the list, talk to the list and retrieve it by position. So there's how you would get motor number 2.
Yeah. Oh, it is.
What should it print out?
B. Well, you want to tell it print out, but you want it to get. That's not going to work until you have to compare it.
What should it print out? I'll put some stars in here just so that we can see the difference. A, B, or C? Okay, so lists are numbered from 0 instead of from 1. So it's going to print out the last one on the list. The 0, 1, 2 is actually the third one on the list. Okay, so it prints out C. Well, suppose I wanted to find out how many items are on the list. How would I find out how many items?
Set that to 0 and then create a while loop.
What's Daryl's Java rule? Who do you want to talk to? All motors, because hopefully they're fairly smart. What do you want to say to them? What thing looks vaguely appropriate there?
Last thing, fix the object.
Okay, notice all the help stuff is right here for you. Okay, so another thing about having the IDE is that you sort of stop reading the documentation and you just type, oh, here's the name of the smart thing. This list is apparently fairly smart. Let me type its name, dot, gee, I wonder what sorts of things I can say to it. Okay, there's all sorts of things that you can say. List is apparently quite smart because there's lots of things that you can ask it to do, but the most interesting one, quite often you can turn around and say, well, I think it looks like it should be size. Okay, so unsurprisingly, the list is smart enough to keep track of how many things are on it, or you can just go ask and it will tell you. Okay, So now that we've got the size, we can just print out the number of items. Item count. And it should print out size is 3. Okay? Just to go back to all motors for a second here. This is going to be fairly typical of a lot of Java that you see. I said list has got, however many it is, 20 different things that you can say to it. Even though something has 20 different things that you can say to it, chances are pretty good that there's only 1 or 2 or 3 of those 20 things that you say over and over again, and everything else that's there is something that's for a very special case. Okay? And one of the problems that you'll see with documentation of this type is that it's the here's everything you can do with no examples sort of documentation, which is actually really, really awful. So there's people that say, oh, just go read the manual and you can find out, no names included. The problem with that is that what you're really looking for is a sample of the things that I do fairly frequently, and if you saw that in the documentation, you would go, oh, okay, there's all the stuff, only stuff I ever need to use. And so I'm not going to show you a whole bunch of stuff about list. I'm going to try to show you the things that you would use on a day-to-day basis, because the rest of the stuff is sort of special case, and if you need it, you can go look it up. Okay? So, now that we've figured out that we can find out how to get a specific item, and we can find out what's the total number of items, now I'll write a counted loop for you. So, we'll start some index at 0. I is less than maximum number of items. How many items are on the list? Which is really, where did we get that from?
0, 1, 2.
So I'm going to eliminate the variable here, and I'm just going to use this value because that's safer. It's always going to be what we want it to be. I will get incremented each time, and we'll go through. And what should I do now? Go back and look at the code we just wrote. I can't, what motor do I have right now inside the loop?
You can use the value of I to select it.
I can use the value of I to select it. Here's something that went and grabbed one by particular position, so this thing needs to be I, because that's the thing that's going to change, and this could be any old motor. Okay, so we'll retrieve it, and then we'll print it. So this is going to be, we'll print out the serial number, so we'll do like this, so that you see the same idea. And this should be any motor. Okay, and I'll just put some stars in there again, so that we got a little separator here. And there's the other version. Let's just run this one and see if it prints out the same thing. So there's A, B, and C. Okay, so there's the 2 different versions. Which one's easier to use? Which loop structure is easier to use?
Less lines.
This one has less lines in it. Which one's going to be most error-free? Which one has the most number of things likely to go wrong? This one, because what? This thing, if you started it at 1, it would only print 2 of the 3 motors because it would forget that it started at 0. If you made this less than or equal to, what would happen?
We'll go over one more and we get an error, probably.
It would try to do one too many. What happens if you do one too many?
Undefined variable.
Out of the range.
Well, let's just run it and see, shall we? Oh, look. See this nasty red error message here? Java is one of these languages that checks to see whether or not you've gone out of bounds on an array. Not all programming languages do. So in this case, it's saying, oh, you tried to access item number 3 off of the list, but there is no item 3 on the list, so I'm going to kill off the program. Now, if you're looking at this code, it looks like there's this little stack of items that we've seen before. So our main program called get called something that did a range check in array list, and then it died. When you see something that looks like this, what I always do is I go back to the thing that I know belongs to me, that I can see in amongst all the gobbledygook. And so I know that I own motordriver.java. And if you click on that line number, it takes you to the line number in your code, which is where it died. Okay? And so now I can say, well, it died on that thing because I tried to retrieve item number 3, but there's only 0, 1, and 2 on the list. Okay? So it actually printed out all of the items, A, B, and C, and then it died when it tried to print the non-existent D position. Okay? So that's what that stuff means. So this style of loop is very error prone, because you either mess up on the first one, you mess up on the last one, you mess up on where you stop on that dividing line, just like we saw before. Yet, if you go and look at people's code, that's the most common one that they use. Why is that, just out of interest sake?
Because no one thinks to try the other, no one thinks you can do it.
You're taught this way, and that's just the way.
People were taught that way, but if you think about where computers came from, this is back to this 1940s thing, that computers were originally done to do mathematical calculations, and typically mathematical calculations involving arrays of things. Okay? And so if you're doing math, those array indexes are very important because that's how math is done, go through all of these items. Okay? And so that tradition of using arrays and using that mathematical sense of positioning is something that's just existed in programming for a long time, and everybody gets taught how to do it that way. Okay? But remember that I said that anytime you see a loop like this, the loop in modern programming usually means go through all of them. Okay? And so that's why you can still read that gobbledygook syntax as soon as you see a for loop as, oh, my intention is probably to go through all of them and just print them out. And so what happened in modern programming is people came along and said, well, if you're just always going to go through all of them anyway, then why don't we write a loop syntax where you don't have to worry about what number of item am I getting now, and we'll just make something that changes the variable to go through all of the ones. Okay? And notice that in this syntax up here, since this is just go through all of them and you don't have any control over going through all of them, the guarantee is that you will get the first and the last and all the ones in between all the time. Okay? And so in a modern programming world, this for each concept, go through for each of the ones, is something that's been added only in the last probably 5 to 10 years in programming languages as a recognition that that's what you do most of the time. So we'll make the syntax easier and we'll make it less error prone. Now, in Java, it's slightly silly. The reason it's slightly silly is I would actually like to say something like for each here. And I would actually like to say something like, instead of that semicolon, I would like to make it more Englishy so that it says, for each motor, some motor in all of the motors, right? Reads really, really nicely. The reason they didn't do that is because this was an add-on to Java in the last 5 years, and they didn't want to use the word in here because it wasn't a keyword originally, and there are lots of Java programs that have the word in already in them, and it would have broken a whole ton of Java programs. So they had to use a symbol that they had already, so they used the colon for that thing. And the same thing applies to there. When they originally defined the language, they didn't reserve the word for each, so they had to make do with a word that they already had, so they used the for word instead. Okay? So if I'm reading this out syntax-wise, you'll hear me read it as for each motor, some motor in all motors. And I'll basically do the translation in my head to make it sound Englishy-like. If I'm not interested in reading you the syntax at all, I'll just say, go through all of the motors and do something. And in general, that's what I'm going to try to do, to just remind you that that's what you almost always do in loops. Okay? So even though that counted syntax is available, it's generally very error prone, and if you can, we're going to stick with this syntax. Why would you ever use this one? There's some cases where it's important that, if you're searching for something, as soon as you find it, you want to stop and you want to know where it is on the list. And so if there are specific reasons why you need to know where it is on the list, then we'll worry about that.
Can you ask the item what index it
But
is?
for now, that's what we're stuck with. Okay? And we'll play with the list some more tomorrow.